Hello students. Let us solve the question from waves and oscillation. The question says a load M is attached to a spring of force constant K and stretched is through X and released. It makes oscillation in vertical plane with a time period T. It is further pulled down through another X and released. Now the time period of vertical oscillation will be. So this question is from a spring mass system, a vertical spring mass system. Now a mass of M is attached to a vertical spring. Mass of M is attached to a vertical spring and stretched to a distance x. Now at this distance the downward force will be mg and spring force will be F upward. So the time period for this oscillation is 2 pi square root m by k. So here notice that time period is proportional to 1 by k, or time period square is proportional to 1 by k. So we have to find the value of k for both situations. In this case the spring constant is k. Now the spring is further pulled another x distance. Therefore the force will be F equals to kx. Now force is the gravitational force, mg equals to kx. This is the first case, and in second case the spring is further pulled, so the force will be mg equals to k, and the x will be increased to 2x. So let us say this is k dash and this is k. So k dash will be mg by 2x, and here k equals to mg by x. So mg by x is k. So k dash will be k by 2. Now see here, time period is proportional to 1 by t square. Time period square is proportional to 1 by k. So for the second case, when a spring is further extended to a distance x, the time period will be t dash square will be 1 by k dash, and k dash is k by 2. K dash is k by 2. So 2 will be come to the numerator. So the time period of oscillation square will be proportional to 2 times of t. So which option will be correct? Second option is the correct answer to this question. Hope you found the solution understandable. Thank you.